Section 6.2, using substitution to solve systems. In Section 6.1, we solved systems by graphing, which is okay. There are some problems with it. First off, your graph needs to be fairly accurately drawn in order to reasonably see what your answer is. The bigger problem is, let's say you draw your graph and your answer doesn't come out to be nice. And what I mean by that, if you look at the problems we did in the last section, the answers came out to be nice. They came out to be things like 2, -1 and -3, 4. What if the answer came out to be 2.7536, -1.852? How long would you be goofing around with your graph to actually see that answer? My guess is a long, long time. Now, graphing over the past few years actually has become a very popular way to solve systems of equations using a graphing calculator. Your graphing calculator can solve and get that crazy decimal answer that I just gave you. But what we're going to do instead is we're going to do the next couple of sections, section 6.2 and 6.3, and we're going to learn some algebraic methods of finding the solution, even when the answers don't come out to be nice numbers. And the method we're going to use in section 6.2 is called substitution. Okay, so here's what substitution looks like. I'm going to give you some steps here. Step 1. Pick one equation. Doesn't really matter which one, but we'll see that sometimes one is better than the other. Pick one equation and get one variable alone. And I'll give you some hints when we do that as to how to try to make things easy for yourself. Step 2. Substitute your solved equation into the other equation. And that's why it's called the substitution method. And we'll see what that means in a minute here. 3, solve the resulting equation and step 4, plug in to find the other variable. All right, so this is most easily explained through some examples. Let's say I give you 2x plus y equals 18, y equals 4x. Okay, step 1 is pick one equation and get one variable alone. Well, this is a great system of equations for doing substitution because I already have that. That equation already has y alone. Y is all by itself. Y equals 4x. So that step 1 is done for me. I like that. Step 2, substitute your solved equation into the other equation. So what I'm going to do is I'm going to take this 4x right here, and I'm going to plug it in right there. I'm not going to write the letter y anymore. I'm going to write 4x. So that gives me 2x plus 4x equals 18. So notice what I have now. I have an equation that only has one letter. And we know how to solve equations that only have one letter. Combine my like terms. 6x is 18. X is 3. So there's step 2. And step 3, solve the resulting equation. And now a common mistake I see students make is they stop right here. But we really need to find both letters. We found x so far. Now we need to find y. You take x and plug it in anywhere you want. I'm going to choose to plug it in right there. Y equals 4 times 3 is 12. So my final answer, I would write it as 3, 12. My final answer. All right, let's try another one of these, one that's a little more complicated. How about 2x plus 3y equals -1. X plus 3y equals -5. Okay, step number 1, pick one equation and get one variable alone. In all honesty, it makes no difference which equation you pick. and which variable you pick. You will get the same answer if you do all the steps correctly. However, the goal here is really to make things easy for you when you can. And what I mean by that is I see a lot of students who will do this and they will always take the first equation and they will always get y all by itself. While that's not wrong, they're making life hard. What I look for is I look for one of the equations to have a variable that has a coefficient of 1 or negative 1. Fancy words. What I mean is I'm looking at the second equation and I'm noticing that on this second equation it's very easy to get x all by itself. I can get x all by itself without having to divide by anything. And that's really my goal. My goal is to get x by itself or y by itself without having to divide. So I would take this second equation and I would write it as x equals minus 3y minus 5. I subtracted the 3y on both sides. Much easier than taking either of those two equations and getting y alone. If I take either of those equations and get y alone, eventually I have to divide by a 3, which means I'm going to get fractions. And my experience is students don't like fractions very much, so we try to avoid them. All right, so I take that answer and I plug it into the other equation. So I plug it in right there for x. So I'm not going to write x, I'm going to write 2 times, instead of x, I write minus 3y minus 5 plus 3y equals negative 1. And now I need to solve that equation. I use a distributive property. Negative 6y minus 10 plus 3y is minus 1. Combine my like terms. Minus 6y plus 3y is minus 3y. Minus 10 is minus 1. Add 10 to both sides. Minus 3y is minus 1 plus 10 is 9. Divide y equals negative 3. Again, not quite done. What I got to do now is take that and plug it in. I plug it in anywhere. I choose to plug it in right there because I already have x all by itself. So x would be, when I plug negative 3 in, negative 3 times 3 is 9. 9 minus 5 is 4. Final answer, 4 comma negative 3. All right, 2 more problems here, and we'll be done this section. How about 3x minus y equals negative 2, and 12x minus 4y equals 9. Okay, again, I start by looking for the easy one. And what do I mean by the easy one? I'm looking for a letter where the number in front of it is a 1 or a negative 1. I see that in this first equation here. My y just has a negative in front of it. So I'm going to take this equation and I'm going to get y all by itself. So I subtract 3x minus y is minus 3x minus 2. And then I have to multiply everything by negative 1 to get rid of that minus sign. Multiply by negative 1. Negative 1 times negative y is y. Negative 1 times negative 3x is 3x. And negative 1 times negative 2 is 2. So I get y all by itself because it was the easy one. Again, I avoided fractions, and that's really a big lesson here. Take this and plug it into the other equation. And always make sure you use the other equation. I'll see sometimes students will solve one equation and plug it right back into itself. And that doesn't help. All right, so what am I going to have here? I'm going to have 12x minus 4 times 3x plus 2 equals 9. Distribute 12x minus 4x, 12x minus, got to distribute the 4 through, 12x minus 8 equals 9. Something strange here happens. The x's cancel out. I get minus 8 equals 9. When does minus 8 equal 9? I hope your answer is never. Minus 8 never equals 9. What does that tell me? Well, what that tells me is these lines never cross. Negative 8 never equals 9, so these lines never cross. This is an example of 2 parallel lines. This is an example of no solution, or The book will write inconsistent. I don't care which answer you give me as long as you say no solution. No solution would probably be the best answer. All right, last example. We have x plus 2y equals 5 minus 3x minus 6y equals negative 15. Once again, I look for the easy equation. The easy equation here is the first one. I can very easily get x all by itself. I don't have to divide by anything. X equals minus 2y plus 5. Take that. Plug it in there. I have minus 3 times minus 2y plus 5 minus 6y equals minus 15. Distribute. 6y minus 15 minus 6y equals minus 15. And again, an interesting thing happens. The y's cancel out. I get minus 15 equals minus 15. When does minus 15 equal minus 15? Always, I hope, is your answer. Those are always equal. So what does that tell me about these two lines? Well, that really tells me these two lines are exactly the same. I have one line lying on top of the other. This is two lines, two different equations for the same line. The fancy math word there is dependent. But again, I would accept if you simply wrote they're the same line. All right, well, notice what happens. You're going to see this happen every now and then. Every now and then, you're going to get something which is obviously true. Minus 15 equals minus 15. That's always true, so your answer is same line. Or if you want to use fancy math words, dependent. Or you might end up with something like the previous example where you get something that's clearly wrong. Minus 8 equals 9. Minus 8 never equals 9. That tells you that there's never an answer. No solution. Inconsistent.